Hello. In this lesson, we're going to get our final tool that we use to solve linear systems. Just to recall, really the whole goal for the chapter is to find where two lines cross. We started off by doing that graphically, and we found that graphing is not always great because the two lines might not cross at an integer value in regard to the intersection point. In the last few lessons, we've been working on the tool of substitution. You might realize, though, that substitution sometimes can be a little bit of a labor-intensive task. It has quite a few steps. And so today we're going to get the first version of our last tool. We'll get to that here in a moment, but to start, I'd like to try this warm-up question, just reviewing what the prior section was on, which was applying substitution in word problem type situations. So you can either complete this where at the bottom of where you completed the last homework assignment, or even just at the top of the note packet that corresponds to the lesson for today, which is on simple elimination. So here's the situation. It says, during a football game, the parents of the players sold pretzels and popcorn to raise money for new uniforms. They collected $336, and they sold twice as many bags of popcorn as pretzels. How many of each did they sell? Just so that we all agree on the variables, let's let x equal number of popcorn sold, and y is going to be number of pretzels sold, because making them both BP would be hard to keep track of. So your goal is just to set up the two equations that we would eventually be trying to solve. You don't need to solve it here, just practice setting it up. And then that is it. So pause the video now for maybe a minute. That should be enough time to give you a chance to try it, come up with the correct solution, and then unpause it once you've had a chance to try. So pause the video now, please. Okay, here we go. The first part was just, if I underline it here, nope, underline it, there we go. This first sentence is just what allowed us to define our variables. Once we have our variables defined, then we can write the equations. It said they collected $336. That's the money equation. So what? $2.50 for every popcorn plus $2 for every pretzel has to equal $336. The last part that they told us is they sold twice as many bags of popcorn as pretzels. So that means popcorn is equal to 2 times as much as pretzels, which was y. Now I have my two equations. That's all you had to do. In order to solve, this would be a substitution, where I take 2y and I'm going to substitute it in for x in the other equation, because x is equal to 2y, so instead of writing x up here, I'd write 2y, and then I could go and solve. But you were just practice setting it up. That's it. We're going to start then with the lesson for today. And so at the top of the note packet, you would see there's two equations. I like you just to add the two equations. So what would that look like? Well, it's very similar to what you did in elementary school when you added in decimals. You added like maybe your decimal place, your ones, your tens. We're just adding like terms here. So I would add x's to x's, y's to y's, numbers to numbers, and just see what happens here. So if I add the two equations, 3x plus 2x is 5x. Y plus negative y is 0y, those just go away. 4 plus 6 is 10. Then I divide by 5 and I get x equals 2, and already I have half of the point of the intersection. I know those two lines are going to cross at 2, comma, something. That's a lot less work than substitution. Let's try it again. Add the two equations. 5x plus 7x, that's 12x. 2y plus negative 2y, hey, that's 0y's. 23 plus 13, that's 36. Now the y's are gone. I can easily solve for x by dividing both sides by 12. So divide by 12, just to show the step on this one. And I get x equals 3, and already I'm halfway to the answer. I know x is 3. How do I get y? I put 3 back in for x in either equation. So you'll see this takes a lot less work. However, when does it work? Well, it works in really specific scenarios. So it's less frequently occurring. So it's more rare that you'd have two equations set up to be solved using this tool. This tool is called elimination. You can see because one of the variables gets eliminated. So it would work when either your x's or the two examples that I showed here were your y's, when they match up. What do I mean by match up? It means the number of them are going to be the same. So 1 and 1 or 2 and 2. In this case, they have to be opposite signs. We'll see here in a moment they could be the same sign as well. We're just going to be subtracting. So when does this work? It works when the coefficient in front of either x or y. The coefficients are the numbers in front of your variables when those are matched up. So it's fairly rare, but when it does, it's very, very, very quick and very efficient. So I want to talk real quick. So that's when it works. I want to mention before we go practicing a few more, like, why does this work? Like, how can I simply just add two equations and have that mathematically be like valid? Well, this is the reason why. Let's go back to this first one of 3x plus y equals 4 and 2x minus 1 equals 6. Let's say for this equation, the first one, I want to add 6 to the right-hand side. I'm going to draw a dotted line down just to keep my sides separated here. So if I add 6 to the right-hand side, you've been told all along when you're solving algebraic equations, what you do to one side, you have to do to the other. So if I add 6 to the right side, I would technically need to add 6 to the left side. Well, the benefit on the right is that 4 plus 6 makes 10. Those are like terms that will work with one another. However, over here on the left, I have 3x plus y. If I try to add 6, that 6 can't communicate with the y. Those aren't like terms. And it can't communicate with the 6. Those aren't like terms. So I need something that is equal to 6 that is going to have like terms with x and y, that can communicate with x and y. And that's where this second equation comes in. The right side I added 6 to. The left side, instead of writing add 6, let's write add 2x minus y. That's the same that's the same weight as 6, so it's a valid step. So I am literally adding 6 to both sides. Maybe I should do it in red here because I did them in red on the other side. I'm literally adding 6 to both sides. It's just the left side doesn't look like the number 6, but it's 2x minus y, and in this specific situation, that is equal to 6. That's what allows me to then add my like terms, get 5x equals 10, divide by 5, and get x equals 2. So now I know that the x-coordinate is 2. How do I go and solve for the y-coordinate? I put 2 back into either the first x or the second x and solve for y. Let's do the first one since the first one has a positive y. So then I would have 3 times, don't write x, I write 2 now, plus y equals 4. Well, 3 times 2 is 6. 6 plus y equals 4. Subtract 6 from both sides, and I get that y equals negative 2. So those two lines should be crossing at 2, negative 2, and indeed they do, if I show you what the two lines look like graphically. So the reason this is valid is because you are literally adding the same thing to each side. One of them is a number term, the other one is the variable representation of the equation, which allows you to talk to the x's and the y's. Let's try a few more. So here we go. I've got 2x minus 2x. So in this case, the x's are going to cancel each other out. So if I go adding the two equations like we have been doing, 2x plus negative 2x, that makes 0 x's. 3y plus 5y is 8 y's. 11 plus 13 is 24. And then 8y equals 24, divide both sides by 8, and I get y equals 3. So those two lines should be crossing at a y-coordinate of 3. Once I know that the y-coordinate is 3, how do I get x? I put 3 in for y in either the first or the second equation. I think last time I did the first one, let's do the second one in this case, just to show it does not matter. So I have negative 2x plus 5 times 3 equals 13. Negative 2x plus 15 equals 13. Subtract 15 from both sides. I then get negative 2x equals negative 2, divide by a negative 2, and I get 1. So the x-coordinate is 1. Those two lines should be crossing at 1, 3. And indeed, they do. So another example of using elimination. We're going to try one more, then we're going to write down our steps that we're using, kind of generalize what we've been trying. So second one before we write down the steps that we've been using. Let's try adding here. That's what we've been doing all along. 4x plus 5x is 9x. 3y plus 3y, uh-oh. For the first time, neither the x's or the y's canceled each other out. So let's go back here. See why that didn't work. Well, the reason it didn't work is because 3y plus 3y makes 6y. So the y's, they need to be eliminated because they match up, but I'm not going to use addition here. I'm going to use subtraction. So you can use subtraction as well. So when would I use subtraction? If I have the same sign, these are positive 3y's, then I'm going to subtract. On the last one, why did addition work? Because the x's had opposite signs. So if the signs are different, you're going to want to add them together. If the signs are the same, you're going to want to subtract the two equations. You technically don't need to memorize this. You can always just try one, and if it doesn't work, it has to be the other. But if you don't want to have to go back, then you'll have to remember that if the signs are the same, you should subtract. If the signs are opposite, then bringing them together through addition will get them to eliminate. Now this should work out. 4x minus 5x is negative 1x. 3y minus 3y is 0y's. This is where you got to be careful with subtraction because everything subtracts. People forget down the line, they'll just start adding. 2 minus negative 2 is 4 because it becomes minus and negative is a plus. Now divide both sides by a negative 1, and I get my x-coordinate is negative 4. So I know that those two lines are going to cross at an x-coordinate of negative 4. Now if I want to solve for y, I put negative 4 in for the first x or the second x and solve for y. It doesn't matter. Let's do the first one. So 4 times negative 4 plus 3y equals 2. That's negative 16 plus 3y equals 2. If I add the 16 over to the other side or add it to each side, I'll get then 3y equals 18. Divide by 3, and I get that y has to be 6. Those two lines should be crossing at negative 4, 6. And indeed, they do when I showed it to you in the picture just a second ago. They cross at negative 4, 6. Zoom it back out so you can see all the steps. So in this one I subtracted because my signs were the same. So here are the steps that we've been using. Then I'll have you try one. The first step that we did was we added or subtracted to eliminate one of the variables. When do we add? We'll add if the signs are opposite or different, meaning one's positive, one's negative. We will subtract if the signs are the same. That means both positive or both negative. Step 2 is once you've eliminated one of the variables, then you solve for the variable that remains. Step 3 is once you have the value of the first variable, you can plug that back into either of the original equations and solve for the other. You did this step when we were doing substitution. Technically, the only real new step is step 1, the elimination step. Then the other step is very similar to substitution. Solve for the first variable once you have its value, plug it into the other equation, and solve for the other. So there's all 3 steps. If we need to pause it to make sure everyone has all the notes filled in, go ahead and do so. If you're reading this on your own, you can pause it until you're ready to move on. But I'm going to move on to the next part where I'm going to ask you to try one. So I'd like you to try to solve this system. Tell me where these two lines cross without even graphing it. That is, instead, use elimination. So pause the video now for maybe a minute and a half, 2 minutes. Give everyone a chance to try. Come back once we're ready to check our answers. So pause the video now, please. Okay, welcome back. Here we see the y's are what I need to eliminate. They are opposite in sign, so I'm going to add my two equations. 4x plus negative 2x is 2x. Negative 3y plus positive 3y, those eliminate. 5 plus negative 7 is negative 2. Divide by 2, and I get that x is negative 1. Once I know that x is negative 1, I can substitute into either of the original two equations. Let's do the second one. Negative 2 times negative 1 plus 3y equals negative 7. That's 2 plus 3y equals negative 7. Subtract 2, and I get 3y equals negative 9. If I divide by 3, I get that the y-coordinate is negative 3. And there it is. I should get an answer of negative 1, negative 3. And indeed, I do. Last part is about as tricky as today can get, and that is sometimes you might need to rearrange. It might not be quite lined up for you. So if you look at this first top equation, it's set up like we've seen before. X on the left side, y on the left side equals a number. This side has x's and y's on opposite sides, so I need to get them lined up. I need my x's, my y's, my equal sign, and then my numbers. So it looks kind of like this actually. So what do I need to do? I need to subtract the 3x from each side so that this will be lined up. So what this will end up looking like is the 8x minus 4y will equal the negative 4. When I subtract the negative 3 over, I'll then get minus 3x plus 4y equals 14. Now it's set up. I'm going to solve using addition because the Signs are opposite, negative 4 and positive 4. 8x plus negative 3x, that's 5x. Negative 4y plus 4y is 0. Negative 4 plus positive 14 is 10. Divide by 5, and I get x equals 2. So I know that these two lines are going to cross at 2 comma something. I then put 2 into either of the original. I could do the top equation, I could do the original bottom equation, or I could even do the new bottom equation, doesn't matter. Let's do the original bottom equation, which was 4y equals 3x plus 14. So we'd have then 4y equals 3, and instead of writing x, now I know x is 2 plus 14. So I get 4y equals 6 plus 14 is 20. Then divide by 4, and I get y is 5. So I know that those two lines are going to cross at 2 comma 5. If you had a graphing program do it, or you graphed it for yourself, you would find that 2, 5 is where those two lines cross. So sometimes you might need to rearrange first. Get your x's lined up, your y's lined up, and your numbers. But you might need to move something over the other side so its sign will change. And I'm going to have you try one just like that, and then that will conclude our lesson. So pause the video now, try one just like the one we did where you might need to rearrange. Come back after a minute and a half, 2 minutes, after everyone's had a chance to try one like this for themselves, and then you are well prepared for today. So pause the video now, please. Okay, if you look, you need to get your x's on the left side, so you need to subtract 4x from each side. Get rid of it on this side. So it'll look like this once everything's lined up. 2x plus 5y equals 12. Negative 4x plus 5y then equals 6. Your y's are matched up and they're the same sign, so you need to subtract the two equations. 2 minus negative 4, that makes 6x's, and the y's will cancel out. 12 minus 6 is 6, so x equals 1. If x equals 1, you can solve for y by putting 1 in for x in the original second equation. So 5y equals 4 times 1 plus 6. That gives you 5y equals 4 plus 6 is 10. Divide by 5 and you get 2. So those two lines should cross when x is 1 and y is 2. And indeed you see, they cross when x is 1 and y is 2. There you go. Thank you very much and have a good day.